All right, we are solving systems with substitution when one variable is isolated for us. Now there's 4 steps. The first step is to solve for one variable in one of the equations, if that's necessary. Step 2 is to substitute the expression into the other equation and solve for the value of that variable. The third step is to substitute that value into one of the original equations and to solve for the value of the second variable. And then lastly, we write our answer as an ordered pair in the order XY. Okay, so let's start with an example. We're going to do 3 examples. And the first is x equals 5 and y equals 2x minus 3. Okay, so our first step is to solve for one variable. This is already done for us, and actually both of our equations, we actually have a variable solved already, so we can skip that step. The second step is to substitute the expression into the other equation. So we're going to take our value for x and we're going to substitute this into our second equation. So we're replacing the value. So I'm going to rewrite this, y equals 2 times 5. So we're replacing x with 5 minus 3. And then we're going to go ahead and solve here. Remember, when we're solving, we're using PEMDAS or GEMDAS, so that means we multiply or divide before we add or subtract. So we're going to start by multiplying 2 times 5, which is 10. And lastly, we subtract. So we have y equals 7. Okay, so we substituted and we solved. In another example, we would have to substitute this back into one of our original equations to solve for x, but here x has already been solved for us. So we can skip that step and we write our final answer as an ordered pair. So here we have 5, 7. Remember, x comes first in your ordered pair. All right, let's do another example. So let's try x equals 2y and 2x plus y equals 10. So our first step is to solve for one variable. Again, that's already been done for us. Okay, we already have x isolated here. So we're going to take x and we're going to substitute it into our second equation. We're replacing it. So we're going to rewrite this as 2 times 2y, because we're replacing 2y with x, plus y equals 10. All right, remember we're multiplying first, so we want to multiply 2 times 2y, which is 4y, and we rewrite the rest of our equation. Remember to rewrite every step. This is really important so that we don't make any silly mistakes. Here we have 2 like terms, so we're going to combine our like terms, 4y plus y. Remember, we can pretend there's an imaginary 1 in front of our y here, so we can pretend this is 4y plus 1y, which would be 5y, equals 10. And the last thing we want to do is isolate our y, so we do that by dividing each side by 5. Our 5's cancel out, and we're left with y equals 2. All right, so now that I've solved for y, I want to plug this back into one of my original equations to solve for x. It doesn't matter which equation. I'm going to pick the first one. It just seems a little easier. So here we have x plus 2y, and we're substituting this in for y. So this is x plus 2. Oh, I'm sorry. This is x equals 2y. So we're substituting x equals 2 times 2. So this is x equals 4. And so now we have the value for both of our variables, so we can write this as an ordered pair. So this is 4 and 2. All right, let's do one more example here. Just gonna get another piece of paper. So our last example will be y equals negative 3x plus 1 and 2x minus y equals negative 6. So this one's a little longer, it's a little trickier, so that's why I wanted to do this example. So we start out by solving for one of our variables. Again, that step has already been done for us. So we're going to take this y, and we're going to substitute it into our second equation. So let's rewrite our second equation. This is 2x minus y. So it's really important that we're including that minus sign there. Okay, we don't want to forget about that. And then we're substituting y here equals negative 6. Now the first thing I want to do is distribute this negative sign here. We're going to do the distributive property. And again, remember we have an imaginary 1 here. So this is an imaginary negative 1. And I'm going to distribute my imaginary negative 1 all the way across this expression here. So this is 2x negative 1 times negative 3x is positive 3x. Remember, a negative times a negative is a positive. Negative 1 times positive 1 is negative 1. And then I rewrite what I have left. So equals negative 6. My next step is to combine like terms. So we're combining 2x and 3x, which will give me 5x. And then we're rewriting what we have. So this is 5x minus 1 equals negative 6. And I want to isolate for x here. So I'm going to start by just isolating this term, my x term. I want to get rid of my negative 1, so I add 1. Everything I do to one side of my equation, I have to do to the other side of my equation. My negative 1's cancel out, and we're left with 5x equals negative 5. Okay, and last, again, we want to isolate that x, so we divide by 5 to each side. My 5's cancel out, and I am left with x equals negative 1. All right, so we've solved for x, and now we still need to solve for the value of y. So I need to take x and I need to substitute it back into one of my original equations. It doesn't matter which one, I can choose. I'm gonna choose the first one. So this is y equals negative 3x plus 1. Okay, I just rewrote that same equation. And I'm gonna take x and I'm gonna substitute it back in. So this is y equals negative 3 times negative 1 plus 1. Okay, so I just took that negative 1 and I substituted it. All right, we're going to multiply negative 3 times negative 1, which is positive 3. And then I'm rewriting what I have left. All right, so y equals 3 plus 1. 3 plus 1 is 4. So now I've solved for y. And I can write my answer as an ordered pair. So this is negative 1, 4. Remember, we always start with x in our ordered pair.